Good day. In this video, we are going to see about inductance. What is inductance? Inductance is defined as the ratio of the voltage to the rate of change of current. That is, inductance depends on the voltage and also the rate of change of current. Inductance is the property of an electrical conductor by which a change in current flowing through it induces an electromotive force in the same conductor and in any other nearby conductors. So this is an inductor. Basically, inductor is a wound of coils. So this is an inductor. So when a change in current is flowing through this inductor, an electromotive force will be acting on the same conductor as well as the conductors which are nearby. Inductance. The inductance is directly proportional to the number of turns in the coil. Also, it depends upon the radius of the coil and the type of material around which the coil is wounded. That is, the value of inductance depends on the number of turns of the coil. So that is how many times you have wounded it, and also the radius of the coil, and also the type of material on which the coil is wounded. The inductance is represented by capital L, and the unit of inductance is Henry. What is an inductor? Inductor is a passive electronic component that stores energy in the form of magnetic field. So basically, inductor is used as a storage device which stores electrical energy in the form of magnetic field. For more information on passive and active devices, you may refer to the video on active and passive devices. Kindly refer to the comment section for the video link. Inductor symbol. The first one is the symbol of inductor with air core, in which the coil will be wounded on air. The next one is the inductor with iron core, in which the coil will be wounded on iron. The third one is the inductor with ferrite core, in which the coil will be wounded on ferrite. The fourth one is the symbol of variable inductor. The voltage across the inductor is given by V is equal to L times di over dt. Here is an inductor which is represented by L, and the voltage across the inductor is V, and the current across the inductor is I. But the current across the inductor will be varying with time. So the current across the inductor will be di over dt. So the voltage across the inductor is given by V is equal to L times the current across the inductor is di over dt. So it is V is equal to L times di over dt, where V is the voltage across the inductor, L is the inductance of the inductor, di over dt is the rate of change of current with respect to time. The inductance can be calculated using the formula L is equal to V over di over dt. We'll get this equation by rearranging the previous equation. So that is L is equal to V over di over dt. That is L is equal to V over di over dt. In this inductor, when the current is constant, the voltage will be zero. That is, when the current flowing through this inductor is not varying with time, the voltage will be zero. And when the current increases, when the value of the current increases, the voltage will be positive. And when the current decreases, the voltage will be negative. The current across the inductor is given by di is equal to V over L times dt. We got this equation from V is equal to L times di over dt. By rearranging this equation, we will get di is equal to V over L times dt. Now integrating this equation, we will get I is equal to integral ranging from 0 to t V times dt. At t is equal to t0, the equation is I of t is equal to integral of t0 to t v of t times dt plus I of t0. This is the current equation for the inductor. Uses of inductor. Inductors are used in inductive proximity sensor, that is used in traffic lights to detect traffic density. It is used in tuning circuits to select the desired frequency, that is it is used in radio to select the particular frequency. It is used to choke an AC supply and allow only DC to pass through a circuit. It is used as a storage device to store energy for a small period of time. It is particularly used in switched mode power supplies. It is used in induction motor, transformers, relays and so many other machines. Inductance measurement. The inductance is measured using oscilloscope and function generator connected together or using an LCR multimeter. LCR multimeter is L stands for inductor, C stands for capacitance and R stands for resistance. So using this LCR multimeter you can measure the inductance of an inductor. I hope you got some idea about inductance and inductor. Thanks for watching this video.